We're going to do two models today. The first one is exponential. Technically, that is an A-B topic, so you'll have to let me know if you remember it. Actually, you do see it in pre-calc as well. We'll see what you guys remember from it. The way the sentence is going to be, you're going to see this written into your questions. The rate of change, derivative, of a quantity, which usually we're going to call y, but if you're talking about a population, it could be p, or they might change the letter of that. But the rate of change, so the derivative, is proportional to the size of the quantity. So the way that's going to look, if we just use y, is dy dt, it's your rate of change with respect to time, equals, and is proportional to the size of the quantity. The quantity is y. Proportional to means you're going to have a coefficient in front of that. In other words, you scaled it. The example I always use is, the Eiffel Tower in Paris? Okay, you can buy a keychain that looks exactly like the Eiffel Tower, and it is proportional to, like dimensionally it looks the same, but just scaled down. It's proportional to, you just scaled it by something, okay? Now we're going to solve the differential equation, all right? We're going to divide the y over, so it'll be 1 over y dy. And then we're going to multiply the dt to the other side, so k dt. As a heads up, this is like we're going to shove every letter of the alphabet into this. I kind of love it. It sort of looks like alphabet soup, right? So what is your antiderivative for 1 over y? Yeah, ln y, there's like not even any numbers, it's all letters, equals, now k is a number, so pretend it's like 2 or something. You're doing an antiderivative for dt, so your antiderivative for k, kt, do you get what I'm saying? Pretend it was like a 2, it would be 2t. All right, it's kt plus c. And just wait, there's going to be one more letter brought into the mix, because how do you get rid of the ln? E. Now, e actually is a number. It stands for a value of 2.7-ish, but I just think it's funny that there's all these letters all over the place. So y equals, when you get rid of the absolute value, typically you put what? Okay, but we're going to do story problems with this, and you typically don't have negative values for things, so we just usually don't write the plus minus, okay? E is a number, C is a number, so typically we just put that out front. So it would be C e to the power kt. That sounded like familiar? You saw before? Where this shows up, when I taught pre-calc, the way that I taught it was this. And everyone remembered it because it spelled a word, which is pert. We shouldn't be doing anything else on the computer. We're not using it at all right now. We're just holding on until we get to Desmos. Do you remember pert? Did you ever learn pert? I like pert better. And if you want to use pert instead of kekt, all right, I feel like it makes more sense because P stands for the principal. That's the amount you start with. And R stands for rate. So I feel like these letters of the alphabet make more sense. But I'm going to write it this way because in calculus, these are the letters they use. All right. C is your initial amount. So whatever you started with. And K is the rate. But if you want to put R instead of K, honestly, I feel like that makes more sense. Also, pert is a word. Everyone tends to remember it better than kekt. Okay, but anyway, that's your exponential model equations. Let's do a few problems. There, you're going to see K. All right. I like R better because R stands for rate, and that just makes more sense to me. K equals rate is alphabetically doesn't make as much sense, but you're going to see K. Right? Rate of growth of bacteria is proportional to the number present. When you read that and see that is proportional to the number present, you need to know it's this formula. You should immediately go, okay, that's what I'm using. That's what that sentence should signal to you. Oh, it's exponential. All right, and if you want to write pert, you can do that. So let's start with some numbers. There are 300 bacteria initially. So it's going to be y equals 300 e to the power kt. And then you have to find K. You have to find your rate. Real quick, is the amount of bacteria going up or down? Are we increasing or we're going up? So your rate should be positive. Love it. Okay. So we're going to plug in 700 for our amount of bacteria. That's the, Y is the amount. You could use B for bacteria, I suppose. Equals 300 e to the power K times 10 is our time. I always cancel out the zeros first. You can kind of go about this however you want. Typically, it's calculator allowed, but I would cancel out the zeros on each side, and then you're going to divide over the 3. So 7/3 equals e to the power 10k. And also, as a side note, don't go to the calculator until you're kind of all done. You don't want to type multiple things. You just want to do it all in one fell swoop. All right, to get rid of e, you're going to do ln. So ln 7/3 equals 10k. And I'm going to share my screen, and here's where you're allowed to use your computer. We're going to all type this together to get our k value. So you're going to type ln of, oops, I didn't bring up Decimus yet. Give it a second, it's just being slow. This is not a very powerful computer. All right, ln parentheses 7/3. And then what else do we have to do to get k by itself? Yeah, divide by 10. So divided by 10. It will be a decimal, but it should be positive is the point. The bacteria amount is increasing. So did you get 0.084? Cool. What is the actual question? Because that's not the answer. They didn't ask for what's the rate. They asked for what? Just read. Oh, write an equation. Okay, sorry, I even got ahead of myself in my mind. All right, so writing your equation, it's going to be y equals, and what was c? What was our initial amount there? 300 e to the power 0.084 times t. And I'll stop sharing so you can see that bigger. I thought I could just do it all at once, but didn't work out that way. I want you to be able to see it. So this is your answer. We wanted the equation. And then the next one, what is the number of bacteria after 20 minutes? Well, we're going to go to our calculator and we're going to type in this, but time is going to be 20. Perfect. Make sure you copy paste that decimal that is your rate. If you only truncate, it will not be accurate enough. And here, I'll show you. I'll do it without copy pasting. You guys copy paste, and I'll show you how mine is wrong. Okay, I'm going to do it wrong. I'm just going to type 0.084 times 20. It won't be accurate to enough decimal points. Do you see how I got, what did you all get? Well, you shouldn't have. Mine's wrong. 1.63333. Yeah, did you get something with a 33333? Yeah. That's what you should have gotten. If you don't type, or if you don't copy paste the entire decimal, let me show you. If we copy paste this, instead of just typing those 3 decimal points, now it'll be correct. There, 1633.3333333. If you don't copy paste that decimal and get all of the decimal points in there, it's going to be wrong. It will not be accurate enough. It's bacteria.
So if we're talking about like things like bacteria, is it okay to have a decimal?
Yeah, I don't feel bad decimal pointing a bacteria. Usually if it's people, I don't decimal point them. Even on the AP exam, because one year there was this question about fish in a pond, and part A said round to the nearest whole fish. So technically you're supposed to round to a whole number of fish. But if you put the decimal point accurately to 3 places, they will still give it to you because they have to. All right. Have you heard of doubling time and half-life? Yeah. Is that something we've heard of? Usually in chemistry is usually where you see like a half-life, like how long it takes an element to break down. Doubling time is the time for C, your initial amount, to be twice as much, or to double. Time for C to be twice as much. And a half-life is a time for C to what? Yeah, to be half as much. The important thing to remember is they are both time. They both represent T. Doubling time, people don't usually forget because the word time is in there, but half-life, that's easy to forget that represents a time. All right, so we'll try a couple of these. An element has a half-life of 1,500 years. So years is your big clue there that that's time. Initial amount of 200 grams. So let's start with that. We've got our 200 as our initial condition. And after 1,500 years, there should be half as much. It doesn't say how much is half as much. You need to be able to figure that out. If you start with 200, what's half as much? 100. So 100 is your amount, and 1,500 is your time. 1,500 goes in for T. It takes elements a long time to, decompose. Don't ask me about the science, though. I don't understand it. All I can do is the math. Yeah, it's half as much, right? I always cancel out the zeros, and oh my gosh, if you start to solve this, the first thing you're going to do is divide by 2, and you get a half. Isn't that crazy since it's a half-life? All right, 1/2 equals 1,500K, and we're going to divide by 1,500, so let's go to our calculator. So here's where you're allowed to have your calculator out and be typing this in with me. Oh, did I not put I'm so sorry. That's kind of important. That's the whole thing that makes it exponential. Equals e to the 1,500K, and then we're going to ln. Thank you so much. Ln of a half equals 1,500K, and then we're going to go to the calculator. I'm going to pause real quick, though, because someone's knocking on it. All right, so we're going to share. Did you guys type it in yet? Should have gotten a really small decimal. Is it negative? Why is it negative? Yeah, you're getting half as much. The amount is breaking down, or the element is breaking down. All right, so ln of a half, and then I want to divide by, 1,500? Oh, that is a very, very small decimal. Again, it takes things a long time to break down. Now, that number is not the answer to the question, though. Read, what does it say to find? After 10,000 years. So we're going to say y equals, and you can kind of see it on this little screen I've got down there, but I'll read it to you. Y equals, what did we start with? What was our initial amount? Yeah, 200. Good. E to the power, that number, can I just write K? Is that okay? Here, I'll write it. Negative 0.0004 times, bless you, 10,000. So here's what we're going to type in. And make sure you copy paste or it's going to be wrong. 200 e to the power, copy paste this thing. Times 10,000. I got 1.968. What did you get? Did we get 1.968? Okay. And what is the units?
Grams.
Grams. Good job. If I got a number bigger than 200, how would we know that's wrong? You can't half it and get more than what you started with. That would be magic. All right. Try one more of these. All right, you put $500 into an account, takes you 6 years to double. So start with that 500. You're going to have y equals 500 e to the kt, or if you want to put r instead of k, that's fine. And it doesn't tell you how much you have, but it does tell you it doubled. So if you start with 500, you end up with 1,000. E to the power k times 6. Took 6 years, and years is your big clue that that's a time. 6 years to double. And then I won't forget to ln this time. So ln2 equals 6k. Now we're all going to go to the calculator. So we're going to type ln2. I'm going to actually just fix what I've got here. ln2 over 6. Is it a positive decimal? Yes, because your amount of money is increasing. Do you guys understand how interest rates work? You can put money in an account and then accrue interest. All right, and then so to get our actual answer, we started with how much money? Was it 500? 500 e to the power. Yeah, and don't just type 0.11 though. You gotta Yeah, copy paste. And I know some of you have told me copy paste didn't work on the version when you took the actual AP exam. Then what should you do? If you can't copy paste every single decimal, I know that's annoying, but it won't be right unless you have the whole thing. Let me just finish this thought real quick. And then how many years were we going to have go by? 8. Now, real quick, if you started with 500, if it doubled in 6 years, in 8 years, your answer should be more than 1,000. More than doubled. So good. I got. Do you get how you should check to make sure your answer makes sense? Like, so that if you get an answer that doesn't make sense, you can go, oh, I typed something wrong in my calculator. Because if you hit even one button wrong, the whole thing's going to be wrong, which is really unfortunate. Thank you for letting me finish my thought. Go ahead.
So if we are on the AP, can't we like what's it?
Right? So go ahead and flip over. So that was exponential. Now we're going to do our logistic equations. Wakey, wakey. All right. This is a brief sketch of what a logistic model would look like. And typically this is used for population growth. You have an initial amount of, give me an animal that lives in the wild and we'll just make something up. Koalas. All right, I heard koalas first. So you have an initial amount of koalas. We'll say this is our initial amount of koalas that we introduce into the wild. Okay. What happens is your amount of koalas starts increasing, right? As populations do. It's going to be concave up for a little while. Do you see how I made that concave up? It's bending upwards. You're going to have an inflection point, and it's going to change to concave down. And what's going to happen is the population is going to level off at this value that we call L, which is your limiting value, or it can be called a carrying capacity. But what happens is you get enough koalas. I know we were just having that conversation. You get enough koalas that you can't go above that amount of koalas because there isn't enough resources. There's not enough like leaves for them all to eat. I don't know about koalas, but you get what I'm saying? They won't all have enough water. And if it goes above that amount, unfortunately, what's going to happen to some of your koalas? Yeah, and that's going to go back down. Okay. So this inflection point conveniently, and this is really nice about this, happens at L over 2. So you have this carrying capacity, and that inflection point happens exactly halfway. Math is neat sometimes. It's exactly halfway every time. Cool. Cool. Okay. So if your amount, which we're going to call Y, is between 0 and that L value. Oops, I was almost going to write L over 2. So if your amount of koalas in our example stays between 0 and L, then their rate will keep on going up. This will be positive. Your rate will be positive. They will keep making more koalas. But if they get above that L value, like somehow it gets above this asymptote, then what's going to happen is, unfortunately, some of them are going to, die. Okay. So if you go above that carrying capacity, then your rate is going to become negative until it gets back below the carrying capacity. And then it will once again become positive. They'll keep reproducing and making more koalas and until there becomes too many of them, and then it'll go back down. So, it's nature balancing things out. All right. Your rate is fastest at the inflection point. So at that L over 2, that's when the rate is fastest, which kind of makes sense from a graphing standpoint. I don't want to draw all over my picture because I actually did a pretty good job of it. But do you see how if I drew in a tangent line that it would be steepest there? Okay, so at that inflection point is when your rate of growth of your population is going to be the fastest. That's all cool, and I like having that conversation. That all makes sense to me. And then the equations are such a mess. Like have something be incorrect, right? So here's what the equation is going to be. Y equals L over 1 plus, and then it kind of looks like the one we just did on the other side of the paper, that Keck formula, but it's a negative K. So there's that. And then, unfortunately, there's two different versions of how the dy dt can look, and they're both correct. So sometimes they might give you one, and sometimes they might give you the other. The one I use more often is k times y and then times L minus y. So that's the one you usually see like more often. And the other one is k times y and then 1 minus y over L. I'm just going to pause there and have a brief conversation. And I tell all of my BC classes this, not AB, because that's fine. In Calc BC, the thing with this class is each topic by itself is not all that hard, but there is more information in this class than it's really possible to memorize all of it. We're not even done. We're not even close to done. We're almost halfway, okay? When we go to review for the AP exam, you're going to have to make conscious decisions about which things you're going to memorize and which things you're going to let go. And I'm not going to tell you which things need to be which. I'll tell you what's more important than what, but this might be one of those things that you have to just make a conscious decision about and go, okay, I'm going to let that one go and focus on this thing. Do you understand what I'm saying? Because what's a good grade? Like slightly above half. Okay, so you just need to make some conscious decisions. That's just my like fine print on that. All right, but these problems aren't actually all that hard. A deer population follows this growth, 40 deer initially. What is the carrying capacity? You're not going to do any work. You're just going to find it in the formula. A number. I need a number. Carrying capacity. 4,000 is the answer. Ding, ding, ding. Move on to the next one. That means if there become more than 4,000 deer, what's going to happen? Nature is going to, fix that, and the rate will become negative again until it gets below 4,000. All right. At what value of P is the population growing the fastest? Growing the fastest is at that inflection point, which just so happens to be this divided in half, which is 2,000. So you see what I'm saying? Each topic by itself is not all that hard. That was very simple, but you have to memorize it. So you just have to make some decisions. All right, for what values of P is the graph concave up and concave down? I'm going to just draw a little picture here. How many deer did we start with? All right, this is 40, and it's going to level off at 4,000. So we're going to be concave up to start with, and then concave down, and this halfway point is at 2,000. I just draw a picture because visually it makes sense to me. So concave up is going to be this portion, and that is happening between 40 and 2,000. So concave up is from 40 to 2,000. I understand that looks like an ordered pair. Do you understand it's an interval? It's from 40 to 2,000, all right? And then concave down would be from what amount of deer to what amount of deer? Yeah. 2,000 to 4,000. Again, was that hard? No, but you have to memorize it. And when you're in the middle of the AP exam, logistic equations are not going to like float to the surface of your brain super easily as maybe some other things, okay? Number 5, here's your model. Do you see how that follows this pattern? Or do you see it? All right. So verify that your carrying capacity is 4. You want to do limit as time goes to what? You've got this. It's as time goes on. There you go. Infinity. You want time to just go on indefinitely and show that it's going to level off at 4. So limit as t goes to infinity of, I'm not going to read that thing. Now, do you see how it's e to the negative exponent? So instead of positive infinity, that would actually be negative infinity. So instead of being a really, really huge number, this whole thing becomes like 2 over, like what is 2 over a million, billion, trillion, gazillion? Like essentially 0, essentially nothing. That whole portion goes to 0, and then 4 over 1 is 4, which we knew was going to be the answer already. They just said to verify it. So we just showed the steps that verified it, right? Point of inflection, we're going to use our calculator for this, okay? But we know what the y value is going to be. Isn't it just 2? Why is it 2? It's the y value, Okay, so I'm going to share my screen. We're going to go to our calculator. You're going to practice typing it in with me. So we're going to type first y equals 2, because we want that to be in there. And then in the next one down, you're going to type that horrible equation, okay? I'm not, please don't make me read it. Can everybody just type it? Oh, also, when it says t, instead you want to type x so that it'll show up. And then you get that lovely little logistic model. Oh, did you find it already? See, this is the only thing with you guys having your computers open while I'm teaching. I can't see all the screens, so I don't know what you're doing. So I just assume you're doing what I told you to, and if not, it's on you. All right, so I knew that the y value was going to be 2. I got 0.231 for my x value. Is that 0.231? All right. You guys are handling this very well. These logistic models, sometimes I get kicked back over them. All right, last one. Maximum capacity of a population of foxes is 500. That's your L value at a particular time. When you go to your delta math, it's going to say at time, and they'll give a number. You don't need that, though. It can be any particular time. Do you get what I'm saying? The time does not actually matter. So if they say at time 7, throw that out. You don't need that. At some time, the population is 128 and increasing at a rate of 20 foxes per week. Okay, so let's label all this. This is what? 500 is L, good. The amount of foxes is 128, so that's Y. And then 20 is your rate. So 20 is dy dt. Rate is a derivative. All right. So I'm going to use that first version of the differential equation. Here, I'll just write the whole thing. Dy dt equals ky L minus y.
So if that's k just a number.
We're going to find k. Just like on the other side of the paper, k was the thing we don't have. That's what we're trying to find.
So both dy, so you said, I thought you said k is also a rate.
Not for this one. This one's more complicated than that. The exponential ones are pretty simple. It's like PERT and it's real straightforward. This is a little more convoluted. Correct. Yeah. Well, no, dy dt is the rate of change of the amount of stuff. Yeah, I mean, I guess you could think of it that way. All right. What am I doing? What was L? L was 500. What was dy dt was 20. You're just plug and chug at this point. 20 equals k times 128, and then 500 minus 128. Now your goal is to find k. I don't want to have to write all that stuff all over again. So can you just tell me what we're going to type in the calculator to get k by itself? It would be 20 and then divided by all of that. Okay, cool. Can we all go ahead and just do that real quick? You're going to do 20 divided by all of that mess. All right, so let's see. 20 divided by, what was it? 128. Where is it? 128 times 500 minus 128. All right, did you get 0.00042000? Okay, here's what I want you to do, because this is how it is on your delta math. You have to turn it back into a fraction. Do you see this little blue circle with a little fraction inside? You're going to click that, and it's going to turn it into a fraction. I got 5 over 11,904. Okay, cool. Thank you for confirmation. So your answer to the whole thing, stop sharing so I can have my back up here, is going to be dy dt equals, it was 11, was it 5 over 11,000, was it 904? Okay, parentheses, and then what, oh, y, and then parentheses 500 minus y. And that is the answer. Don't discriminate. It's a great answer because it's the right answer. I can. I'm going to stop this